let's first of all sketch out the carriages of this train. Okay, there we go. Right, we don't know how many people are in each carriage, so I'm just going to label it A, B, C, D, and E. But what we do know is that two passengers are said to be neighbours if either they're in the same carriage or in an adjacent carriage, and each passenger has exactly 5 or 10 neighbours. So I'm going to focus on somebody in the first carriage. Now, they are going to have A minus 1 neighbours in that carriage, and then they're going to have B neighbours in the next carriage. And that is going to equal 5 or 10, which means that A plus B must equal 6 or 11. Okay, that's a good start. Right, now I'm going to pick somebody in the second carriage. So they're going to have B minus 1 neighbours within their own carriage. Like obviously they're not their own neighbour. That's why I'm minusing 1. And then they're going to have A to the left and C to the right. So that is going to equal 5 or 10, which means that A plus B plus C must equal 6 or 11. Now, these A, B, and C, they're all positive integers. So there's no way that A plus B could be 11 and then A plus B plus C could also be 11 because we're told that every carriage contains at least one passenger and definitely it couldn't then equal 6. So what I'm trying to say is basically A plus B must equal 6, not 11. And then because of that, it must be that A plus B plus C is actually equal to 11 because we've already got 6 and then we're adding something on. And actually, we're well on our way to doing this question. So here we've got 6 people in the two carriages overall. And in this carriage, we've got 5 people. Now, there's absolutely nothing special about the left-hand side, so I can make exactly the same argument on the right-hand side. I'm not actually going to write out the equations. Feel free to do that. But we're going to, in the same way, show that there's 6 people here. Okay, there must be a symmetrical strand to this question. So overall, it's going to be 6 plus 6 plus 5, 17.